Okay, after you've reviewed your different types of triangles, you have isosceles, equilateral, obtuse, acute, etc., etc. You can use that information to solve for missing sides and variables. So let's take a look at this problem here. We have find x and the measure of each side of the given equilateral triangle. So here they're telling us this is an equilateral triangle. Well, if this is equilateral, then we know that all of these sides are congruent. So I'm just going to go ahead and label all these sides congruent. Okay, now looking at the picture here, if all these sides are congruent, I know that all of these sides here must be equal. So I'm going to go ahead and set myself up. I can pick any two sides. I'm just going to go ahead and pick these two here just because they look nice to me. So I can write x plus 9 is equal to 2x. And if I solve for this here, I could subtract x from both sides. That'll give me 9 equals x. And I've solved for my one variable. Now if I want to solve for the missing sides here, all I have to do is, since the only variable in these is x, is plug in my x here for all the x's up here. So I'm going to go ahead and do that. Here I have my side SR. This is equal to x plus 9, which is going to equal 9, plugging in 9 for x, plus 9, which is 18. So now I have my side SR. Next, let's go ahead and do RT. So I have my side RT. That's going to equal 3x minus 9, which is going to equal 3 times, instead of x, I can put 9, minus 9. This is going to give me 27 minus 9, which is going to be 18. Which, since we know that all these sides are congruent, it only makes sense that SR and RT give us the same value. So we can predict what ST is going to be here. What do you think it should be? Well, since it's congruent to all these sides here, yeah, it's going to have to be 18. Let's go ahead and plug it in just to check. Here we have ST is equal to 2x. Let's plug in our x. That will give us 2 times 9, which indeed is 18. Let's do one more quick example. Find x and the measure if the missing sides, that should say of. Find x and the measure of the missing sides of isosceles triangle EFG. Well, I see isosceles, so I know that two sides have to be congruent and the measures equal in the triangle. Well, they've labeled those congruent marks right here and here, so I know that FE is congruent to FG. Well, if those are congruent, what do you think we can do? Right, we could set those two sides equal to each other. So that'll give me 4x is equal to 2x plus 6. Let's subtract 2x from both sides. That'll give us 2x equals 6. Divide both sides by 2, and we'll get x equals 3. Now if we have x equals 3, we need these missing sides here, EF and FG, so we can choose either one to plug our x value in. I'm going to go ahead and choose EF because that looks nice there with a 4x. It looks rather simple, so I'm going to go ahead and say EF equals 4x, which equals 4 times, and I'm going to plug in my 3. I'm going to plug in my 3 that I had right down here into this x. So 4 times 3, and that's going to equal 12. And that's my answer. Now, can you take a guess? What's FG going to equal? Well, I see this congruent mark here, this congruent mark here. So we can guess it's going to equal 12. And you would be correct. And I'm going to go ahead and solve it out anyway, just to make sure I'm checking everything and everything's turning out nicely. This is going to give me 2 times, instead of x, I'm going to plug in 3 plus 6, and that's going to give me 6 plus 6, which is 12, which is exactly what we predicted. So again, you're just looking at your pictures, you're looking at the information that they give you in the problem, and you're seeing what you can set up and what you can solve. Remember, if it says solve for the missing sides, you don't just solve for the variable, you also have to find the sides that they want you to. All right, good luck. Email me if you have any questions or need help. All right, bye.